Newton's first law of motion, often called the law of inertia, provides a fundamental principle that explains why objects behave the way they do, whether they are still or moving. It forms the very bedrock of classical mechanics, helping us understand the universe from the smallest particles to the largest galaxies. So, what exactly is this law? It states that a body will remain at rest, or continue moving in a straight line at a constant speed, unless it is acted upon by an external force. This might sound simple, but it's a profound concept. The core idea is this: motion does not need a force to continue. An object in motion will stay in motion. Force is only needed to change that motion, to speed it up, slow it down, or change its direction. This inherent property of matter to resist changes in its state of motion is what we call inertia. Think of it as an object's natural laziness or stubbornness. It wants to keep doing whatever it's already doing. The more mass an object has, the more inertia it has, meaning it's harder to get it to change its motion. We can classify inertia into three types. First, the inertia of rest. This is an object's resistance to being moved from a standstill. Second, the inertia of motion, which is its resistance to being stopped or slowed down once it's already moving. And third, the inertia of direction, its resistance to changing its path of travel. You experience this every day. Imagine you're standing on a bus. When the bus suddenly stops, what happens? Your body lurches forward. That's not the bus pushing you. It's your own inertia. Your body wants to continue moving forward at the same speed the bus was traveling, even though the bus itself has stopped. The force from the floor or holding a rail is what eventually stops you. In the vast emptiness of space, where friction and air resistance are almost non-existent, this principle is perfectly clear. If you push an object, it will glide in a straight line forever, or at least until it's pulled in by the gravity of another celestial body. It doesn't need a constant push to keep going. So why do things stop here on Earth? When you roll a ball, it eventually comes to a halt. This isn't because its motion runs out. It stops because of external forces like friction with the ground and air, resistance pushing against it, constantly working to change its state of motion. If you could remove those forces, the ball would just keep rolling. To sum it all up in one simple line, objects don't change their motion on their own. A force is always the cause of any change.